In March 2026, kinetic drone strikes targeted AWS data centers in the UAE. This physical attack tested the extreme limits of cloud redundancy. The attack simultaneously destroyed 2 of the 3 availability zones inside the ME Central 1 region. AWS designs infrastructure like S3 and RDS to require a quorum across multiple zones. Losing 2 zones at once caused these dependent services to fail entirely. Relying on neighboring facilities leaves your data vulnerable to regional conflicts. Protecting critical systems requires placing your backup infrastructure on an entirely different continent. Multi-AZ setups are highly effective against software bugs and isolated power grid failures. But to survive a physical threat, you need immense geographic separation. The problem with multi-region redundancy is that it forces you to duplicate your entire infrastructure footprint. For mid-market companies, this creates a massive financial barrier known as the 100% DR tax. This chart shows how a baseline cloud bill of $100,000 instantly doubles to $200,000 the moment a strict one-to-one regional replica is activated. To fix this, you have to weigh your raw costs against your recovery time objective, exactly how many minutes or hours your business can afford to stay offline. You cannot build a multi-region architecture for free, but by making strategic trade-offs, you can compress that 100% insurance premium down to 15 or 25%. Your single largest cost reduction lever is workload tiering. Tier 0 applications require zero downtime. These banking and payment systems must run an active-active setup across regions, which carries a steep price tag. Most production workloads fall into Tier 1. Here, you use a warm standby strategy. You run a scaled-down version at 10 to 20% capacity, configuring it to burst to full power only during an actual failover. For your Tier 2 non-critical applications, you use a pilot-light strategy. You replicate the database, but keep the compute infrastructure completely powered off until a disaster strikes. Aggressively shifting applications from warm standby to pilot light cuts your disaster recovery compute costs by 80 to 90%. The operational trade-off is simple. You accept a recovery time of 4 hours instead of 4 minutes to make the DR tax financially survivable. Next, apply geographic pricing arbitrage. AWS charges different rates depending on the region, and selecting a low-cost backup location drops your baseline infrastructure costs by up to 40%. Globally, the cheapest regions are US East North Virginia and US West Oregon. These serve as your default low-cost anchors. If data sovereignty laws prohibit US servers, Sweden acts as your optimal low-cost European alternative that maintains GDPR compliance. For organizations with primary sites in Asia or the Middle East, Mumbai offers highly viable compute pricing and very low latency. Conversely, avoid South America for disaster recovery. Setting up in Sao Paulo consistently costs twice the price of the Virginia region. Be aware of the physical limits. Placing a backup site halfway across the world introduces latency that restricts your asynchronous database replication speed. Treating your disaster recovery location as a financial variable secures an immediate 20% discount on your total bill. The fastest way to bankrupt a multi-region setup is ignoring cross-region data transfer fees. AWS charges roughly 2 cents for every gigabyte of data that leaves a region during replication. This flowchart illustrates S3 multi-region access points. They act as a dynamic routing mechanism that intelligently pulls data only from the nearest healthy bucket. Implementing this reduces unnecessary cross-region data fetches by up to 60%. You also must implement pre-transfer compression and deduplication. Shrinking your database and log files before they cross regional lines directly halves the volume you get billed for. Relying on naive bucket replication will silently drain your budget. Disciplined, optimized data pipelines are mandatory. To further cut compute costs, deploy spot instances for stateless web tiers in your DR region. This yields up to 90% savings. But there is an acute trade-off. A failover means your global architecture is already operating in a degraded state. Relying on spot instances means accepting a higher risk of sudden capacity interruptions when you are most vulnerable. You also have to choose how to route your traffic. Standard Route 53 DNS failover costs pennies, but it suffers from multi-minute propagation delays. AWS Global Accelerator guarantees sub-30-second network edge failovers, but it carries a steep monthly fee and premium data processing charges. Gatekeep the premium Global Accelerators strictly for your Tier 0 applications, where seconds matter. Let your less critical apps rely on slower, cheaper DNS routing. None of this architecture matters until you test it. You have to schedule region kill drills to verify that your capacity reservations and key replications actually work. Enterprise Tier 0 systems require active-active setups to survive kinetic strikes, absorbing maximum cost. Mid-market budgets hit the 15% premium by relying on pilot-light architectures in low-cost regions. Regulated entities must negotiate break-glass exceptions to utilize safe foreign regions like Sweden. Keeping 100% of your data localized inside a single country guarantees 100% exposure if that physical region is destroyed. Modern cloud resilience goes far beyond software redundancy. It is an engineered balance of financial limits, legal compliance, and physical geography.